So in this question here, we've got a referee's coin to be tested for bias. Now, the players claim there is bias towards heads on this particular coin. So we're going to set up a hypothesis test to test the claim to the 5% significant level. And we're going to do 10 test spins to work out, see if there is any evidence of that. And with those 10 test spins, we're going to try and find the critical value or the critical region as to where this coin should give us some sort of indication that there might be some bias. So first of all, let's set up the hypothesis test. So with that, you need a null hypothesis and an alternative hypothesis. Now, to test a coin, the standard of that of a coin is 1 heads or 1 tails, a 50% chance of either. So therefore, the standard null hypothesis for this would be 0.5. Now, the alternative hypothesis, just got to be a little bit careful because there's bias towards heads. Now, to be biased towards heads, that would indicate the probability is more in favour of one side than the other. So this is going to be a one-tail test. So therefore, we want the probability is greater than 0.5. So that's going to set up our null hypothesis and our alternative hypothesis. Next, we need to work out what our test statistic is and how we're going to calculate it. So with a coin, you've either got a heads or tails outcome, and we've got a set number of tests. So this looks to me like a binomial distribution test. So binomial is x is distributed bn, p. So x is our random variable, binomial distribution, n is the number of tests, and p is the probability. So for this, x is distributed 10, 0.5. So that's what we've got. So next thing we need to work out is how we're actually going to work out that test. So if we want to work out how many heads is going to turn up on the spins, what we need is a cumulative distribution. So on our calculators, we need the binomial CD function. And that will give us the probability x is less than or equal to some integer k. Now k can be from 0 to 10, as there's going to be 10 test spins. So that's our setup for how we're going to calculate. And what we need to look out for with the 5% significance level, we want 95% of the data or more to be within the area of our critical region. So what that means is when we put in our value, probably x is less than or equal to some value of k, we need a number greater than 95% or 0.95. So let's put some values in there and see what comes out on our calculators. So to show this bias towards heads, we want more than 5, of course. So let's try 7 and see what that gives us. So probability x is less than or equal to 7. So that's the probability we get 0, 1, 2, 3, all the way up to 7, all added together. So that will throw out 94.53%. So that's 0.0547 . So that's not quite in our region of our 5%. So 0.0547. So let's try 8. So that's going to be all of the chances of getting a heads from 0 up to 8 inclusive. So put that in our calculator, we'll get 98.93%, which is approximately 0.0107. Now that falls into our critical region. So therefore, probability x is less than or equal to 8. That's all the values added up together to get this. So therefore our critical region, or even critical value if you like, is x is greater than or equal to 9. So therefore the only chances we'll have is if we get 9 or 10 to be heads. So critical value would be 9 or 10. And if we get that, that would mean there is sufficient evidence to reject the null hypothesis and accept the alternative hypothesis. Anything of 8 or less, then we have to accept the null hypothesis that there is no bias. But any of these, we can reject the null hypothesis and say there's evidence towards some bias in the referee's coin. Okay,